Find the zero and multiplicity of polynomial. So I'm going to start with an example number 1, x plus 1 to the third power, x minus 2 to the second power, and x plus 3 to the first power. So I'm going to graph that on decimals. As you can see, there are 3 x-intercepts at -3, at -1, and at 2. So I'm going to cut and paste to this screen. To find the zero, we can just simply solve each of the factor from the given functions by setting up each of this equal to 0. So if you make, for example, the first one, if you set x plus 1 equal to 0, then that's going to give you x equal to a -1. Okay, so that's an example of how to solve for x. Then you would have the solution as x equal to a -1, x equal to 2, x equal to a -3 by setting up each of the factor equal to 0 like this and then solve for x. Now, in terms of vocabulary, when they're asking to find a 0, that's how you do it. When they're asking to find the solutions, that's how you do it. And when they're asking to find the root, that's how you do it. You do the same thing. So what about base is on the graph? What is the graph look like for each of the solution and at each of its multiplicity? So let's take a look at when x equal to a -1. It's right here. And then you can see the graph start from the left. It's kind of slowly going to -1 and then slowly exits out. So this does not go straight through. So it's gonna have the multiplicity of 3. What about at x equal to 2? The graph starts from the left. Let's go to 2. And it bounces right off. So let's go back up. So at x equal to 2, the graph did not go through the x equal to 2. So it's gonna have the multiplicity of 2. Now at x equal to a -3, so you can see the graph start from the left, go straight through. So it's going to have the multiplicity of 1. So that's how you identify the solutions, the 0, and multiplicity at each of the x-intercept. So moving on to example number 2 to the right hand. So they're asking that given the degree of this graph, so they provide you the graph, they give you the graph. Let's say the degree of this graph is 6. Find all the 0 and multiplicities. So to find the zeros, just look for the x-intercept. So we're going to have the 0 at -3, -1, and at 4. To find the multiplicity, let's start with x equal to a -1. Why? Because the graph just goes straight through it. So that's easy to say that x equal to a -1, it has multiplicity of 1. What about at x equal to a -3? So the graph starts on the left, it's going to -3, but then it's bounced off. It's going back up right away. So you can see that look like letter U here. So it's going to have the multiplicity of 2. And at x equal to 4, the graph starts from the left, slowly going into 4, and then kind of flat it out, and then slowly exit out and go up. So it's going to have the multiplicity of 3. So all this multiplicity must add up to the degree of 6 from the given questions. And I can write my equations just based on the graph like this. X plus 1 to the first power, that is multiplicity of x plus 1, and x plus 3 second power, and x minus 4 to the third power. So let's summarize the lessons. The first thing that I noticed that for any polynomial that has the factors of the variable x minus a number h with the powers of a number a, the h is going to be the zero of this polynomial. And we can also say it's also the solutions, the root, the x-intercept, and is going to have the multiplicity of that power a. Now for a polynomial that have many factor like this, to find the degree of this polynomial, you need to find the sum. That is mean you add all the exponent from each of the factor. So you're going to add a plus b plus c to get the degree of this polynomial. For example, you have x plus 1 to the third power, x minus 2 to the second power, x plus 3 to the first power. This gonna have the degree of 3 plus 2 plus 1 equal to 6.